Hello children, how are you all? Hope you all are doing well. This is VKM. Welcome to Electron Chemistry Center. In this video, we will be starting with a new topic for today's class. The topic is from alcohols, phenols and ethers. That is especially from alcohols topic. The topic name is Pinacole Pinacalone rearrangement. Pinacole Pinacalone rearrangement. Before going to the topic, it's a kind request for all of my students and whoever are watching, and please subscribe to channel and share it to many. I can make many and many more lecture videos for free of cost. So please like the video and subscribe to my channel also. Let us start the lecture. So this pinacole is nothing but it's a dye substituted. It is a, simply we can say that rather than simply giving it as dye substituted, we can write it as diol. It's a diol and it is a ketone or aldehyde. Substituted ketone or aldehyde can be taken it as a pinacalone, and diol is taken as a pinacole. Actually, what is a pinacole pinacalone rearrangement means? Acid catalyzed rearrangement. Acid catalyzed rearrangement of vicinal diols. As everyone are aware of it, diols are nothing but two age groups are adjacent to each other. Vicinal diols, which are called 1,2 diols, to ketones are aldehydes. Ketones are aldehydes. Acid catalyzed rearrangement of vicinal diols, that is 1,2 diols, to ketones are aldehydes. This conversion is called as pinacole pinacalone rearrangement. So let us try to understand with the help of an example. If I take diol like this, condition must be diol. The alcohol which we are taking it is diol. It's a vicinal diol. It should not be a geminal diol. If it is treated with H plus, let us say dilute H2SO4, followed by heating, and we are going to get CH3, C, CH3, CH3, and here C double bond O, CH3. What is this said to be? It's methyl tert butyl ketone, and this is called as pinacole, and it is called as pinacalone. And the rearrangement is said to be pinacole pinacalone rearrangement. Similarly, you can take one more example: CH3, C, CH3, OH, and here CH2, and it is OH. Same here also, H plus followed by heating, and it becomes CH3, CH, CH3, and it will be CHO. It is aldehyde. Even aldehyde is also said to be pinacalone. Pinacole has been changed to pinacalone, right? Now let us try to understand how this rearrangement actually took place. Let us talk about the rearrangement. Okay. Let us try to understand the mechanism. Let's see the mechanism of pinacole pinacalone rearrangement. It's very interesting reaction. This rearrangement is very interesting rearrangement. I'm taking this CH3 here OH, and I'll be taking a diol. I'll be taking a diol. Now what will happen in the presence of H plus. In the presence of H plus, what will happen? Lone pair of electrons which are present on the oxygen is having lone pair of electrons, right? And these lone pair of electrons is given to H plus. Then it is going to form, if we donate the lone pair of electron, OH, and it is CH3, and here it is CH3, and here it is OH2. Now oxygen develops a positive charge. And if it develops positive charge, obviously we need to polarize the bond in this way. You have to polarize the bond. By that, what will happen? Water molecule can be removed. H2O, we are going to remove it. If you remove the H2O, and what is the next step? CH3, CCH3, here OH, and it is connected to CH3, CH3. Carbon acquires positive charge. Once this carbon acquires positive charge, what will happen? We have to do the shift over here, right? That is 1,2 methyl shift should be done. 1,2 methyl shift we have to do it. So this methyl group is going to shift it over here. If it is shifted over there, so what we are going to get it? CH3, C, and here it acquires positive charge. It is OH, and then it is C, CH3, CH3, and here CH3. Now we got positive charge. Obviously, this H, right? The H, if it takes electrons from the H, we are going to remove the H plus because it is acid catalyzed. We have used H plus, we have consumed H plus in first step. This substrate has consumed H plus. Okay, that H plus can be taken out, and if H plus is removed, and this positive and negative charge can form a bond. Now we got our required product. Check it over there. CH3, CO, CH3, CH3. This is said to be Pinacalone. So Pinacole has been converted into Pinacalone. So such a way rearrangement is done. Now let us try to understand with one more example. Now C6H5. Now I am taking phenyl groups here just for better understanding. And it is CH3, and here CH3 here. This part should be OH, right? It is OH, and here also OH can be taken. Now this is the group we have taken, and it is a diol I have taken, and then we are actually treating with an acid. Now many of the people will get doubt, sir, should I remove, like, let us this OH or this OH should be combined with H plus. It all depends on the stability of the carbocation which is going to be formed. So I'll be actually making this oxygen to donate its lone pair to H plus. Then C6H5, I'm writing it as pH for sake of convenience. Then this is going to form OH2 plus, and it is C, and it is CH3 anyway, it is CH3, and it is OH. I can polarize the bond in this way. So by that, if I polarize this bond, and by that water molecule can be removed over here. If I remove the water molecule, then there is a positive charge can be erased. If a positive charge is erased over here, carbocation is formed, right? So if a carbocation is formed over here, CH3, CH3OH. So this carbocation is more stable because it is stabilized by resonance. For suppose if I remove this OH, let us assume if I remove this OH in the form of water, now if I get carbocation here, let us say at this position, if I get the carbocation, which I am labeling it here, see this position, if I get the carbocation, then that is stabilized by hyperconjugation. 6 hyperconjugate structures are possible. But if I generate the carbocation here, it is stabilized by resonance. And hence, I have removed this OH in the form of water. So now we got a carbocation. Then what we are going to do? We are going to do the shift. This methyl group is going to migrate it over here. That's 1 comma 2 methyl shift can be done. 1 comma 2 methyl shift can be done. If you do the 1 comma 2 methyl shift, that is pH C pH, this one will be CH3 and it is C, and we are going to get the positive charge over here CH3, and it is OH and it is positive charge. Obviously we are going to polarize the bond in this way. If I polarize the bond, what we are going to get pH C pH CH3, and here CH3 C double bond O. This is called as Pinacalone. What is this called as Pinacalone? Hope you understood the mechanism, right? It is a clear-cut mechanism of the Pinacole Pinacalone rearrangement. But now we are actually migrating the alkyl group or hydrogen which is placed over here. Like let us say if you observe it here we have done 1 comma 2 methyl shift. In previous case also we have done 1 comma 2 methyl shift. Sometimes we can do 1 comma 2 methyl shift, 1 comma 2 hydride shift, 1 comma 2 phenyl shift also can be done. In that case, which group can be migrated? So migratory aptitude which can migrate easily, in the sense H greater than aryl, that is phenyl group C6H5 greater than CH3. So this is the migratory aptitude order. If the alkyl group, let us say tert butyl is there, isopropyl is there, ethyl is there, methyl is there, then tert butyl can migrate it easily. How do we know that? Because here we are actually migrating the alkyl group to compensate this positive charge developed over here on this carbon. That means the alkyl group which we are migrating it, that alkyl group should be a strong electron releasing group. If it is a strong electron releasing group, it can actually stabilize the carbocation formed over there. That's the reason we can say that whenever there is a competition, when there is a competition for the migration of a group, which group should be migrated, which group should not be migrated, or which group should be migrated first. In such cases, the competition difficulty can be settled by whichever is strong electron releasing group that can migrate preferentially than the other one. For suppose if you try to understand, let us say if it is having a substituent called OCH3. OCH3 substituent is there. That OCH3 substituent group can migrate faster. It is a migratory aptitude. CH3 than this greater than, and if it is aryl itself, and thereafter Cl which is attached over here, yeah, Cl, because chlorine is electron withdrawing group, that's why electron withdrawing group migratory aptitude is very less, children, in comparison to electron releasing group. So this is the migratory aptitude can be given for a particular substituent. For suppose sometimes the question can be given in this way. Let us say the substituent is like this: OCH3 at ortho position, it's methoxy, and as well as OCH3 at para position. In that case, remember that, children, this para methoxy position rate is very high compared to ortho one because steric hindrance. So due to steric hindrance, it has less rate of migration. Due to steric hindrance, because of steric hindrance, there is a less rate of migration. Less rate of migration. Which one? Orthomethoxy compared to paramethoxy, right? So such a way, a rate of migration also can be given. Now, let us talk about in other compounds. Not only in diols, even we can see the Pinacole Pinacalone rearrangement in other compounds also. What are the other compounds can be given? Even amino alcohols are there. Amino alcohols are there. Yeah. Even amino alcohols also can undergo Pinacole Pinacalone rearrangement. How come? Like let us say I'll be taking this time, okay, pH. CH3 we have already taken. This time I'm taking, okay, pH. Phenyl group. It is CPH and it is OH. and it is CME, methyl group, and it is also methyl group, and here NH2 group is attached. Amino group is there, alcohol group is there. That's why it is called amino alcohol. But we need to do diazotization with nitrous acid at 0 to 5 degrees Celsius. Then NH2 group can be changed into, can you guess it? How it is going to change? Can you guess it? It is going to change into diazonium, right? It is going to change into diazonium. N2 plus is going to be obtained. Now we are going to remove this as a nitrogen. Nitrogen, we are going to remove it. Then we get a carbocation. Carbocation. This is OH, CMe, Me. This carbon acquires a positive charge. Then obviously what we are going to do? We are going to shift the phenyl group to compensate that positive charge here. Now, so then we are going to get pH, C, OH, and here C, Me, and it is also Me. Here pH group has been migrated and this carbon acquires positive charge. Then as a next step, what we are going to do, H, we are going to remove it. In the form of H plus, then carbon, this positively charged carbon, negatively charged oxygen can form a bond. You will get Pinacalone. What we are going to get it? Pinacalone. So such a way, even amino alcohols also can give this kind of rearrangement. And one more also, even halo alcohols also can be taken. Halo alcohols. Halo alcohols also can be taken like CH3, CH, OH, C, and this one will be H, and it is Cl, CH3. But this time we are going to use AgNO3. As you are aware of it, whenever AgNO3 is used, we can remove this Cl minus in the form of AgCl. Then that adjacent carbon, sorry, the chlorine attached carbon acquires positive charge, that you can see it here, CH3, carbon acquires positive charge. But here there is a migratory aptitude use. There is a methyl group and there is a hydrogen group. Which is going to migrate faster? Hydrogen is going to migrate faster. So rate of hydrogen migration is faster. So you are going to do 1, 2 hydride shift. So it will be COH, carbon acquires positive charge because hydrogen has been migrated. So we are going to get CH2, CH3. Now this time we can polarize the bond in this way. H plus we are going to remove it again. CH3, C double bond O, CH2, CH3. Such a way we got a ketone. That can be taken it as a pinacalone. So such a way Pinacole Pinacalone rearrangement is not only possible in diols, it can be possible in amino alcohols, it can be possible in allo alcohols. Hope you understood it and hope you have enjoyed the session. For more and more videos, please subscribe to my channel. And we will meet you in the next video. Thank you children. Thank you very much.